As we start, review topic number 4, which was differential equations, which some of you commented that you had trouble with. I wanted to briefly mention where all of these packets would fall. The first one we did, area and volume. Those are most likely free response question number 1, maybe 2. They come really early. Graphical analysis usually is around number 4. The rates of change, those contextual, I cannot say that word, questions are usually number 2. So all of those that we just looked at would be probably your 1 through 3 problems. They're going to be really early on. Differential equations tends to be number 5 or 6. And when you're only looking at 6 problems, that means these are those final ones that are deciding that between a 4 and a 5 usually. But these can be so easy if you break them down. Okay, so we have a differential equation, which means we have our slope in terms of both y and x. That's really all that is. So on this one, and it's a no calculator, so we have to be careful with that, we need to use these points to sketch a slope field. So what I tend to do is take each point and plug it in. So the first point is -1, 1. So when I plug that in, I shouldn't do equals. So this is going to be dy dx equals. So when I plug in 1 for my y, 1 minus 1 is 0. Times, I don't care, it's still 0. My slope right there is 0. Guess what? Every time y is 1, I'm going to get a 0. So I'm going to go ahead and take care of those. I don't even have to write them down. I can just draw them. So I need to go to the next one. -1, 0. So now when I plug in a -1, oh wait, no, I'm sorry, 0 is my y. So 0 is my y, that gives me a -1 squared is +1. So we're only really concerned about this cosine of pi times x. So that would be cosine of -pi. Now remember, when you're thinking about your unit circle, sine and cosine, cosine would be your x. So -pi would be, well, let's see, here's 0, here's +pi, -pi would be in the same spot. So over there, my cosine value is -1. I'm going to go ahead and do all the other ones that have a y value of 0 because that made it easy. So 0, 0, and then 1, 0. Because when I plug in 0 for y, I just end up getting a 1. So my dy dx here is going to be cosine of 0 pi. Well, it's cosine of 0, which is +1. Then we have cosine of 1 times pi. Oh, that's -1. Now let's look at the next one. This point is -1, -1. Now I already know what I'm going to have for my cosine value. So I need to remember that. But when I plug in y, y is negative 1. For all three of these points, y is negative 1, right? So negative 1 minus 1 is negative 2 squared is going to be a 4. The x value is negative 1, so that's 4 times cosine of negative pi. Cosine of negative pi was negative 1, so this is going to be a negative 4. When I plug in negative 1, I'm still going to get a 4. Cosine of x times pi. Well, that was positive 1 times 4 is a positive 4. Plug in negative 1, we get a 4 cosine of positive 1 pi. That gives me a negative 4 again. So slope of negative 4 is just going to be super steep. And this one's going to be super steep. And this one's going to be super steep. They don't need it exact. But it should be steeper than the slopes of 1. B. There is a horizontal line with the equation y equals c that satisfies this differential equation. Horizontal line that works. Oh! Horizontal line that works, it's y equals 1. So I would say B, y equals 1 satisfies, so C is 1. Part C. Find the particular solution. Okay, so we need to get our y's on one side, our x's on the other side. So this will end up being 1 over y minus 1 squared dy equals cosine pi x dx. Now that's really y minus 1 to the negative 2. I like that because I can actually use the power rule. So we're taking the antiderivative of each side, add 1 to the exponent, divide by that new exponent. So if I divide by negative 1, that's the same as multiplying by negative 1. If I take the antiderivative, what do I take the derivative of to get cosine? Well, that would have been a sine. So let me think about that. Sine of that thing. But I should have used the chain rule. Because if I take the derivative of sine, I get cosine of pi x times pi. Oh, well, what about if I do 1 over pi? Now let's try. 1 over pi sine pi x. The derivative would be 1 over pi cosine pi x times pi. That works. Plus c. Okay, so negative that would really just change the, flip it around, so that'd be 1 minus y. 1 over that would be that equals 1 pi sine of pi x plus c. So, let's see. F of 1 equals 0. So I need to use that information. So let's find our C value. So if I plug in 0, I get 1 over 1, which is 1, equals 1 over pi sine of pi plus C. Well, sine of pi Well, that's 0. So C equals 1. Good. That makes it easier. Okay, so let me go back to the 1 over, I'm going to have to go down here. 1 over 1 minus y equals 1 over pi sine of pi x plus c. Okay. Oops, not plus c anymore. We found c. C is 1. So I've already gotten a lot. I've gotten like 4 points, 5 points. I'm really doing good. Now I need to solve for y. So let's see. If I multiply both sides by pi, I can get rid of pi. Sine of pi x plus times pi would be pi. Now, if I flip both sides, I get 1 minus y over pi equals 1 over sine pi x plus pi. Oh, I should have left the pi over there. Gosh, that was silly. 1 minus y equals pi over all that junk. I'm still trying to get y by itself. Okay, subtract 1. Oh boy, it's almost by itself. Oh, divide both sides by negative 1. This is the solution. Now, I'll go ahead and tell you this part C, was 6 points. You could have gotten 1 point for that. They put in 2 whole points for taking the antiderivative, because you had to take the antiderivative of the left side and the right side. Finding that constant of integration by plugging in the initial condition was another 2 points. It was only 1 point for getting this part. So you could have gotten the majority of your points up here. Okay. Next one. We have our differential equation, and we're supposed to sketch a slope field. So, I take each point and plug them in. Change color so you can see the difference between which problem I was working on, since that one went down there. So, negative 1, 2. So my slope, I can even change it to an m, would be half of x plus y minus 1. So that would be 1/2. So let's see, that would probably be about here would be 3, right? Up 1 over 2 would be staring at that point. So that's how I figure out my slant. I think about where that line would be going next. Negative 1, 1. Negative 1/2 plus y minus 1 would be 0. So negative 1/2, down 1 over 2. This slope would be looking at that point. Negative 1, 0. Negative 1/2 plus y minus 1. So this is going to be negative 3/2. So that one's going to be really steep. So see, down 3, whoa, over 2. It's going to be looking kind of like, more like that. Next one, 0, 2. slope equals, plug in 0, I get 0, plus 2 minus 1 is 1. 0, 1. Plug in 0, plus 0 is 0. 0, 0. Plug in 0, 0 minus 1 is negative 1. 1, 2. Plug in 1 for x, I get a positive 1/2. Plus 2 minus 1, which is 1. So I get 3/2. So that's going to be pretty darn steep. I'm going to do about there. Next one is 1, 1. 1/2 plus 1 minus 1 equals 1/2. So up 1 over 2, kind of be like if I'd gone from here to there. So that would be there. 1, 0. It's 1/2 plus 0 minus 1 is minus 1. That's a negative 1/2. Find, looks like d squared y over dx squared. It's the second derivative. So, with this one, because I'm kind of running out of room, I'm going to get a piece of scratch paper. So, second derivative. So I've got dy dx equals 1/2 x plus y minus 1. All right. So second derivative. And with respect to x, so we're already taking care of the x. That would be 1/2 plus the derivative of y, which would be the slope. And the derivative of a constant is 0. So that's gone. Oh wait, we know what dy dx is. Substitute that in. So second derivative is going to be 1/2 plus 1/2 x plus y minus 1. Now I could clean it up and combine the 1/2 and the negative 1. Sorry about that, my door knocked. So here's our second derivative. And B says that we want to describe the region in which all solution curves are concave up. Gosh. Concave up would be when this is greater than 0. So when negative 1/2 plus half an x plus y is greater than 0. Wait, isn't that really y is greater than negative 1/2 x plus 1/2? If I solve for y? So that means, well, that means the solution curves will be concave up above the line y equals negative 1/2 x plus 1/2. Because remember, greater than a line, you would actually shade above it. Okay. C. Let y equal f of x be a particular solution with the initial condition 0, 1. So, if we have an initial condition of 0, 1, wow, let's see if I can get through this part without getting interrupted again. So we have an initial condition of when x is 0, y is 1. So let's see. It didn't actually ask us to find f of x. It says, does f have a relative minimum, maximum, or neither at x equals 0? Oh gosh. So I need to find out, well, what's dy dx at that point? So what is it when we have the point 0, 1? So I'm going to plug in the point 0, 1, and that was 0 plus 1 minus 1, which was 0. Now, I could test the points to the left and to the right of it, but another way you can find out is if we look at the second derivative at that same point. So I know we have a critical value, right? If I plug into my second derivative, which we found to be, what was it, negative 1/2 plus half of x plus y. That's going to be 1/2, right? It's greater than 0. That means it's concave up. So if I have a critical point, so here's my options. I have this one, a max, or I have a min. Which one is concave up? That one. So concave up, and knowing it's a critical point, that means I have a minimum. It's a relative minimum. Since we're only testing one point, I don't know if it's the absolute minimum, but it's a relative minimum at the point 0, 1. Now it's going to ask us to find the constants m and b that is a solution to the differential equation. So we kind of know that dy dx is another name for, so hold on, dy dx equals 1/2 x plus y minus 1. The wording of this question is so weird, and it actually shouldn't be. Dy dx is another name for slope. It says we're trying to find y equals mx plus b. Replace y with mx plus b minus 1 at the end. And we'll see what we can figure out. So we have m over here equals 1/2 x plus mx plus b minus 1. So if I group those, that's m plus 1/2 x plus b minus 1. So if you have a slope that's 0, that's when this is 0. So that means m is negative 1/2. Now let's plug that in here. We have m equals negative 1/2 plus 1/2 is 0, x equals b minus 1. Oh, I'm sorry, negative 1/2 equals b minus 1. So b is 1/2. Like I said, these differential equation problems are going to be more along the 5 or 6 range. They're going to be your last ones on the test.